Hello and welcome back to my channel. So in this video we'll be completing this 2019 October November paper 1-2 series, that is 8th, 9th, 10th question. So here's the question number 8th A part. Over a 21-day period an athlete prepares for a marathon by increasing the distance she runs each day by 1.2 kilometer. On the first day, she runs 13 km. Find the distance she runs on the last day of the 21st day. So it is like first initially she has started with 13 km and it is increasing by 1.2 km on the daily basis. So it is the arithmetic sequence, you can say. So on here, what is given, A is given as 13 km and D, which is regular interval which is being added, that is 1.2 kilometer, and we need to find the distance she runs on last day, that is on n is equal to 21. So n is equal to 21. So we need to find the u21, that is on the 21st day what is the distance she has traveled. So un, we know it is a plus n minus 1 into d. So here I write a plus n minus 1 into d, and that is 13 plus 21 minus 1, that is 20 into 1.2. So it is 13 plus 12 into 20, 12 into 2, it is 24. So it become 37 kilometer. So on 21st day she will run 37 kilometer. And let's discuss the next part. Find the total distance she runs in the 21-day period. So total distance means it is, they are asking for sum, and we know in arithmetic sequence the sum, which is S21, will write as S21, n is 21 here. It is n by 2, that is 21 over 2 times 2 times a is 13 plus n minus 1 into d, so that is 21 minus 1 into d, that is 1.2. So we need to calculate this. 21 upon 2 into 20, 12 into 13 into 2, 26, plus 20 into 1.2 is 24. So it become 21 upon 2 into 26 plus 24 is 50. So it becomes 21 into 25, because this got cancelled, you got 25, and it is 25 and the 25, 25 to the 50, so 525 kilometer. So altogether in 21-day period she has run 525 kilometer altogether. So here's the B part of this 8th question. The first, second and third terms of a geometric progression are x, x minus 3 and x minus 5 respectively. Find the value of x. So since it is a GP, so there should be a common ratio r, and common ratio is the ratio of the term and the previous term, that is x minus 3 second term upon first term. That should be exactly same as the third term over second term. So if we'll solve these two, we'll get the x value. Let's solve it. X minus 3 into x minus 3, x minus 3 whole square, that is x square minus 6x plus 9 is equal to x into x minus 5, that is x square minus 5x. So these two got cancelled. Minus 5x and minus 6x, I'll transfer this minus 6 at that side, it would become plus 6x minus 5x, and hence we got x value as 9. Here it will give x, so x is equal to 9. So x value is 9, or we can say from here a also, it is the first term, a is also 9, and r, it's not required to write here, but that's fine. A is equal to 9 and r, that is common ratio, will be 9 minus 3 upon 9, that is x minus 3 upon x. It is going to be 6 by 9, that is 2 over 3. It is just for the calculation in the next part. So in the second part, find the fourth term of the progression. So since it is a GP and fourth term u4, I'll write u4, that is fourth term, is given by ar to the power 4 minus 1, and hence it is 9 into 2 over 3 to the power 3, that is 4 minus 1 is 3, and hence it is 9 into 2 cube is 8 over 3 cube is 27. So 9 3s are, it is 8 over 3. I'll write in the mixed fraction because it's improper fraction, and 2 2 3. So this is the fourth term of the sequence of this progression. And the third part, find the sum to infinity of the progression. So since we know r is equal to 2 by 3, which is less than 1, so we can find the sum to infinity, and sum to infinity is denoted by s infinity, and it is a over 1 minus r, that is 9 over 1 minus 2 by 3, or we can say 9 over 1 minus 2 by 3 is 1 by 3, and hence it is 27. So s infinity or sum to infinity is 27. I hope it is clear. Let's do the next question. So here's the question number 9. Functions f and g are defined by fx is equal to 2x square plus 8x plus 1 for all real number, and gx is 2x minus k for all real number, where k is a constant. The first part is find the value of k for which the line y is equal to gx is a tangent to the curve this. So tangent means we'll find by starting with the intersection point, and we'll find the value of k for which there is only one intersection point. One intersection point means, suppose this is the curve y is equal to fx curve, and this is a line, this is a line. So if there are going to be only one point, so this line will be the tangent to the tangent to this curve at one point. So we'll start with fx is equal to gx. So we got 2x square plus 8x plus 1 is equal to 2x minus k, or we can rewrite, because we need to write the quadratic equation where we can use the discriminant property. So it is 2x square minus plus 2x, 8x minus 2x is 6x plus 1 plus k is equal to 0 for one root. For one root, d should be equal to 0, or we can say it is 6 square, that is 36 minus 4 times a times c, that is 1 plus k should be equal to 0, or we can cancel this by 4, or we'll write like that only, and it is 36 is equal to 8 times 1 plus k, or from here 1 plus k is equal to 36 over 8, 9 over 2, and hence k is equal to 9 over 2 minus 1, that is 7 over 2, or 2 3s are 6, 3 1 over 2. So k value is 3 1 over 2, or we can write 3.5. so this is the k value for which this gx will be a tangent to the y is equal to fx. Let's do the next part of it. In this case where k is equal to minus 9, so we can see gx was 2x minus k. So when k is equal to minus 9, g of x become 2x minus 9, and we need to find the set of values of x for which fx is less than gx. So we'll write fx is less than gx, that is 2x square plus 8x plus 1 less than 2x minus 9, or we'll make the quadratic equation. It is 2x square and minus plus 6x plus 1, it is plus 1, it is minus 9, sorry, it is k is equal to minus 9, so it would be plus 9 here, it is also plus 9, and it will become minus 8 less than 0. So now we have a quadratic inequalities, and we know the graph will look like this because x square coefficient is 2, that is positive, and we need to find the root of this quadratic equation. Once we get the value, these two value, we know that we are going to take the part, this part which is below the x-axis, so we'll take the x value in this range. So let's solve it, and here we'll get it as, we can divide by 2, whole equation for a whole inequality by 2, we'll get x square plus 3x minus 4 less than 0, or we can say this as x plus 4 and x minus 1, x plus 4 and x minus 1 less than 0. So from here we can understand what are the roots, minus 4 and plus 1. So this is going to be minus 4 and this is going to be plus 1. So the inequalities for this case, when you require less than 0, so it would be greater than minus 4 and less than 1. We can see greater than minus 4 and less than 1. These are the values of x for which fx is less than gx. So I hope it is clear. Let's do the next part. In the third part, the case where k is equal to minus 1, g inverse f of x, and solve the equation. This we need to find this, and the equation we need to solve the equation also. So first of all, when k is equal to minus 1, g of x will be 2x plus 1, because it is minus 1, it was gx, it was 2x minus k. So from here we can directly write what is g inverse of x. It is going to be x minus 1 upon 2. We can follow the steps also, because we know once we write this as y is equal to 2x plus 1, then y minus 1 is equal to 2x, and hence x is equal to y minus 1 over 2, and that is the g inverse x. And fx I'll write again, fx is equal to 2x square plus 8x plus 1. So g inverse f of x will be g inverse, and let's find the value of for x in this case. The input for g inverse will be 2x square plus 8x plus 1, or from this definition we can get it as 2x square plus 8x plus 1 minus 1 over 2. These two got cancelled, and 2 will also cancel these two. That is g inverse, we got g inverse of f of x will be x square plus 4x. So this is the g inverse f of x. Now we need to solve this. So now we'll solve x square plus 4x is equal to 0, or from here we can take x common and x plus 4 is equal to 0, or we got x is equal to 0 or minus 4. So these are the two values, two solutions for g inverse f of x is equal to 0. In the fourth part, express fx in this form where a and b are constant, and hence state the least value of fx. So fx is this, and we know that we are going to use the completing square method. For that we require the x square coefficient as 1, so I'll take 2 common, and we'll write it as, I'll take the square bracket, x square plus 4x. We'll leave this 1 apart. We are only going to do the calculation here, because for using the completing square method we require this second x coefficient only. So it is going to be 2 times, I'll use the square bracket, and I'm going to complete the square from here, x and half of 4, that is 2 whole square, and subtract the whole square of this, that is 4 plus 1, and hence we got it as 2 times x square plus 2 whole square, and we should not forget to multiply in both, and minus 8 plus 1, and it become 2 times x plus 2 whole square minus 7. And from here we can directly find what is going to be the value of fx, what is the least value of fx, that is minus 7. So least value of fx is equal to minus 7. Here's the 10th question, which is the last question of this paper. And the question is, the diagram shows part of the curve y is equal to 1 minus 4 over 2x plus 1 whole square. The curve intersects the x-axis at A. the normal to the curve at A intersects the y-axis at B. So, and the first part is obtain expression for dy over dx and integration of y dx. So let's find out that first. So for y is equal to this, I'll write y again, y as 1 minus 4 times in from denominator I'll bring it in the numerator, it become minus 2, and then dy over dx is equal to differentiation of 1 is 0 because it's a constant, minus 4 as it is. The power will come in the multiplication and then it would reduced by 1, that is minus 2 minus 1, and we are going to use the chain rule because it's the not single x. So the differentiation of 2x plus 1 is 2. So directly we can write it as minus minus plus 4 to the 8 to the 16 divide by, because this become minus 3, so in numerator it will become 2x plus 1 to the power 3. So that is the dy over dx. Now let's find the integration of this. So it would be 1 integration of this, I'm doing it separately, minus 4 times 2x plus 1 to the power minus 2 dx. It become x, integration of 1 is x, and integration of this will be 4 times 2x plus 1, power will be increased by 1, that is minus 2 plus 1, and will divide by this, that is minus 1, and will divide by the differentiation of 2x plus 1, so 1 upon 2 plus constant of integration. So minus minus it will become plus, and 2 times this. So fx integration of y with respect to x dx is x plus 2 times, and this is minus 1, so it will go a denominator, it will become 2x plus 1 solely, and plus a constant of integration. So that's the value of y dx. We don't have to find the constant of integration. In the second part, find the coordinates of b. So let me bring the figure here. So here we need to find the coordinates of b. We know that in the x coordinate we can directly write is 0, and y coordinates we need to find. Before that, we can find the coordinates of a. It is on the x axis, so y will be 0. I'll put y is equal to 0 here, and I'll get it as 1 minus 4 over 2x plus 1 whole square. I'll write at a is equal to 0, so this become 2x plus 1. I'll bring it here, it is going to be 1 is equal to this, so 2x plus 1 whole square is equal to 4, and hence 2x plus 1 will be plus minus 2. Or from here we can calculate, we cannot take the minus sign here because it's on the positive x-axis side, so 2x plus 1 will be minus plus 2. So I'm going to write directly 2x is equal to 2 minus 1, that is 2. We'll ignore the other part because it's not there on the other side of the, so sorry, this is 2 minus 1 is equal to 1, and hence x is equal to 1 by 2. So at a, the coordinates of a we got it as 1 by 2 comma 0, and now we know what is dy over dx as well from the first part. So dy over dx at a it would be it was dy over dx was 16 over 2x plus 1 to the power 3. So 16 over 2 into x is 1 upon 2 plus 1 to the power 3. These two got cancelled. It is 2 cube is 8, so it is 16 by 2 16 by 8, sorry, and it is 2. So the gradient at a, gradient of a tangent, sorry, gradient of tangent at a is 2. So gradient of, or I'll write directly gradient of line AB will be minus 1 upon 2, because we know the product of the gradients of perpendicular lines should be minus 1. So it is a normal at A, so it is going to be minus 1 by 2, or that's why the equation of line equation of line passing through AB. I'll write equation of line AB directly as it is. Y minus y1 is this 0 is equal to gradient minus 1 by 2 times x minus x1. X1 is 1 by 2. So from here we can write actually y is equal to minus 1 by 2 times x minus minus plus 1 by 4. So the y-intercept of this line will give the b coordinates, or we can say c. If we'll compare it by mx plus c, we can see that what is the c value. C is the y-intercept and it is 1 by 4. So the coordinates of b will be 0 comma 1 by 4. So I hope it is clear. Let's do the next part. Find, showing all the necessary working, the area of shaded region. So let me bring the diagram here. So here's the diagram. We need to find the area of shaded region, and we know the coordinates of a and b. It is 1 by 2 comma 0, and this is 0 comma 1 by 2. It may 1 by 4. So this distance is 1 by 2. This distance is 1 by 4. So area of the triangle, this area of shaded region is divided into two parts. One, this area and this area. So area of triangle AOB is equal to half into base is 1 by 2 into height is 1 by 4. So it is 1 over 16 unit square. Now area of this shaded region, will find the area by highlight area of this area under the curve. Area under the curve is going to be from 0 to 1 by 2, from 0 to 1 by 2, and this y dx, because another is y is equal to 0, so y dx, and y dx integration of this we already know, and that is x minus it was x upon 2 upon 2x plus 1. So it is plus, I guess it is plus from 0 to 1 by 2, and will not, of course, not include the constant of integration because it's a definite integral. It is definite integral, and now it is going to be upper limit 1 by 2 plus 2 over 2 into 1 by 2 plus 1, that is 2, minus lower limit, that is 0 minus 2 over 2 into 0, 0 plus 1, 1, and hence it become 1 minus 2 minus 1, 1 by 2 minus 1 is minus 1 by 2. So this negative area means it is below the x-axis, so the total area we can directly write total area is equal to 1 by 16 plus the positive area 1 by 2, and hence it is 1 plus 8 by 16, that is 9 by 16 unit square. So that's the answer, unit square we can write. So I hope it was of some help. So that's it for this video. Thank you so much.